Hi, welcome back for another edition of Jensen's Doing Some Calculus Problems. I'm here with my two kiddos. This is Jack and this is Bear. Guys, say hi.
Hi. Hi.
We're going to do some jokes today so you guys can get invested in here. I'm going to start with this one, guys. How much does a polar bear weigh? They don't know. Enough to break the ice. All right, here we go. Bear, knock knock.
Who's there?
Dwayne.
Dwayne who?
Dwayne the bathtub. I'm drowning. All right, Jack has a knock knock joke for us too. Jack, go ahead and share your knock knock joke.
Knock knock.
Who's there?
Boo.
Boo hoo.
Don't cry, baby.
And I got one for Jack. Knock knock.
Who's there?
Interrupting starfish.
Interrupted.
I got him. Okay, so hopefully you guys enjoyed my kids for just a little bit. I sent them inside so that I can teach you guys some calculus, or at this point you hopefully have done the Edulastic problem, and this is just checking the solutions to confirm that you did it right. And if you have any questions, maybe I can clarify that for you. So today, here's what we're opening with. They gave us this equation, 2y cubed minus 4y plus 2x squared minus 8x equals 34. And what they'd like us to do is we have 5 different parts. First, for part A, is they want me to find dy dx and show that it's equal to this. Literally what we need to do is take the derivative of this. The only weird part is that we have, we're going to have to do some implicit differentiation and solve for our dy dx. So let's go ahead and work through part A. On part A, I have 2y cubed minus 4y plus 2x squared minus 8x equals 34. What I'm going to do is take the derivative with respect to x. I'm going to take d dx of both sides. D dx. So as I go through this, I'm taking the derivative with respect to x of each part here. So as I take the derivative with respect to x here, this is going to be, you just take the derivative as if it was in terms of x's, and this becomes 6y squared. And then whenever we take the derivative with respect to x of a y term, we create this dy dx term. I continue working my way through. I do this. Again, the derivative of negative 4y will just end up being negative 4. But because I took the derivative of y's with respect to x, I create this dy dx term. Here, the derivative with respect to x will end up being 4x squared, or sorry, 4x, so plus 4x. And the derivative of negative 8x, oh, this should just be negative 4, my apologies. The derivative of negative 8x is just negative 8, and the derivative of 34 is equal to 0. So we successfully took the derivative, but we need to solve for dy dx. I think the easiest way to do that is to move all of my non-dy dx terms over to the other side of the equation, and then I'll group these two terms together to solve for that dy dx. So my first step is moving this over. So I have 6y squared dy dx minus 4 dy dx equals negative 4x plus 8. Then I did this, I moved these terms over, so between these two terms I can factor a dy dx out, getting it by itself. And when I do that, I get dy dx times 6y squared minus 4 equals negative 4x plus 8. And then I have dy dx times stuff equals negative 4x plus 8. I can divide by this stuff to the other side. So when I do that, I get dy dx is equal to negative 4x plus 8 divided by 6y squared minus 4. At this point, I feel like I've solved for dy dx. However, if I look at the answer they wanted me to make this equal to, this is close but not exactly the same. I notice here that they put the x term second, that they have this number here, and a 3y squared minus 2 means that I need to divide everything by 2, which is possible because I can factor a 2 out of the numerator and a 2 out of the denominator. And then I can also reorder my terms. So if I do that, I'm going to do that maybe up here. In the numerator here, I'm going to factor a 2 out and reorder the terms. So I have dy dx equals, I factor a 2 out, and then I have 4 minus 2x. Notice all I did was just reorder those terms. And down here, I can factor a 2 out. And I get 3y squared minus 2. At that spot, I can divide those 2's out, and I don't need the parentheses anymore after I do that. And I get 4 minus 2x over 3y squared minus 2. So you'll notice then, I'm able to show that the derivative is equal to this. My work here, all the steps of my work is my proof that this is actually indeed equal to this. The reason that they ended up giving us here, in this case, dy dx, and showing that it's true, is because later in the problem we're going to end up using this dy dx, and so in case we got part A wrong, they didn't want the rest of the problem to go kablooey for us. Alright, so hopefully you guys get A, and we're going to move on to part B. Alright, so here we go on part B. What they want me to do is find when the x-coordinate, find the x-coordinate where the curve, this original curve, has a horizontal tangent. Remember, a horizontal tangent on our graph would be if the curve was doing something like this, at the spot where the slope is 0, that would be a horizontal tangent line. Luckily, we found the derivative, so what we really need to do is find out when the derivative equals 0. That would be an x-coordinate where our graph has a horizontal tangent. So, if I look at the derivative, dy dx, we found this in part A, but they also gave it to me. Dy dx is equal to 4 minus 2x divided by 3y squared minus 2. If I want to find when this is equal to 0, I just let dy dx, that's my slope, equal 0. And now I have a fraction is equal to 0. And this is where we can make a good mathematical move. A fraction equals 0 when the numerator equals 0. So this is true when 0 equals 4 minus 2x. At this spot I can solve for my x. I can subtract 4 over and divide by negative 2. And so that's when x is equal to positive 2. This is where the x-coordinate has a, this is the x-coordinate where my curve has a horizontal tangent, and we've done part B. Okay, so I'm on to part C here. For part C of this problem, what they want me to do is write an equation tangent to the curve at the point 7, negative 2. And we want to use this line to approximate the y value for when x is 7.1. So, first thing we need to do is write an equation for the tangent line at 7, negative 2. Well, to write the equation of a tangent line, we need two pieces of information. We need a point, and we need the slope. They've given me the point, 7, negative 2, and now I need the slope at that point. Well, luckily we have the derivative, dy dx, and so we can use this point, 7 and negative 2, substituting in 7 for the x value, negative 2 for the y value, and that'll give us the slope at 7, negative 2. Once I have the slope and the point, I could write an equation for the tangent line there. So let's go ahead and do that part first. We have dy dx is equal to 4 minus 2x over 3y squared minus 2. I'm going to put in the point 7, negative 2. So I'll write that up here maybe. 7, negative 2. 7 going in for, substituting in for x. And negative 2 is going to substitute in for my y value. So this on top, negative 2 times 7 is negative 14. 4 minus 14 is negative 10. Down here, negative 2 squared is positive 4. 3 times positive 4 is 12. 12 minus 2 is positive 10. Negative 10 divided by positive 10 is negative 1. So I have the slope at this point, and I have the point. So to write an equation now, I'm going to use the point slope form, y minus y1 equals m times x minus x1. Y1 being this y value. So it's y minus a negative 2 equals m. My slope I just figured out is negative 1 times x minus, my x value here is positive 7. Now if we just needed the line, we would stop right here. We don't need to simplify at all. However, because I'm going to end up using this line to approximate the y value, I'm now going to go further and solve for y on this equation. And what I'm going to do then is, because I have the slope of the tangent line here, I then will use it to approximate where this curve is going to be at when x is 7.1. Notice 7.1 is close to 7. So I'll show you pictorially kind of what we're doing. Is we'll assume the graph is doing something, I don't know, I can't remember what it looked like. Let's say it's something like this. And let's say x was 7 here. Obviously y is not negative 2, so that's a pretty terrible thing. But let's assume it was there. This, then, what I just found is the tangent line at this point. And what I'm using is, I'm using this tangent line to approximate 7.1. I want to get what is the y value of the curve really, really close to that. And so this will be an approximation of our curve. So that's kind of big picture what we're doing. Obviously this isn't the 0.7 negative 2 because I didn't do a good job drawing that. But you guys can imagine what that would look like. So I'm going to take my line here and solve for y. So this will be y plus 2 equals, the negative here will distribute and I get negative x plus 7. I can subtract the 2 over and I get y equals negative x plus 5. What I'm going to do then is use this equation to approximate when x is 7.1. That's what they wanted me to do. So when I do that, I get y is equal to negative parentheses 7.1 plus 5. And negative 7.1 plus 5 is negative 2.1. And now I've answered the question. That the y value when x is 7.1 is approximately negative 2.1 of the curve. Alright, we're working our way through this. We're already on to part D. We're flying through it. Remember, I love some positive feedback. I've been getting those thumbs up. You guys have hopefully been typing in the chat some comments, whether this is helpful for you, or you can say, Jensen, this is terrible. Learn some better jokes. Feel free to submit those to me and maybe it'll make it on the next video. As we get into part D, the goal for part D is to determine the concavity at this point, 7, negative 2. As you'll notice, to continue using the 0.7, negative 2 because we've already established some information from the previous part as to what's true at the 0.7, negative 2. So in order to determine concavity, what we need is the second derivative, and we need to put the 0.7, negative 2 into the second derivative. When we put that point in, if the second derivative is positive, if y double prime is positive, greater than 0, then we are concave up. And if y double prime is less than 0, then we are going to be concave down. Remember, concave up means our graph is looking something kind of like this, and concave down is something like this. Sometimes they ask questions like this with the approximate line to help us determine, like, is this approximation an over approximation or an under approximation? They didn't ask that information here, so I'm not going to get into that. But it's just something to be aware of, and that we did in our notes before. So here we need to take the derivative of our dy dx. That'll give us our second derivative, and that's going to involve some quotient rule, and that's going to involve some implicit differentiation. So it's got a lot of fun in store for us. So here we go. Let me erase this part. When I go to take the derivative of this, I'm taking d dx of the first derivative. This is our first derivative. So I take d dx of this. Here this becomes d squared y over dx squared, which essentially is y double prime. And then over here, this I'm taking the derivative of a fraction, which means we have to use the quotient rule, going way, way back, okay? And so for all of my Jensenites, here's how we did it. Our derivative is always, say it with me, low to high, take away high to low, all over low squared. What that means is the low is the bottom, and I'm taking the derivative of the high minus the high derivative of the low, the bottom function, all over the bottom function squared, or low squared. So first, low is this, that's going to be just 3y squared minus 2 times d hat, the derivative of this is going to be just negative 2, because 4 goes to 0 and derivative of negative 2x is negative 2. So low d high, take away high, which is 4 minus 2x, d low would be the derivative of the bottom function. So the derivative of 3y squared is going to be 6y. Derivative of negative 2 is 0. But remember, when I take the derivative of a y term in respect to x, I create this dy dx. Divided by low squared. Low squared would just be this term squared. So, this is my second derivative. Now, depending on what I'm doing with the second derivative, kind of depends on how much I want to clean this up. For example, I could distribute this negative 2 in here. I could distribute this negative over here. I could say that dy dx I know is equal to all of this stuff and substitute all of this stuff in here. And, oh, I forgot the square. And I can even square out this whole term if I wanted to. I'm not going to do any of that unless I have to. So I'm going to go back to the problem and ask them what do they want me to do. They wanted me to determine the concavity at 7, negative 2, which means I need to put in 7 for x and negative 2 for y. So if you're like me, I think it's a lot easier just to substitute in an x value of 7 and a y value of negative 2 into this problem. And then for this piece, dy dx, well, that's dy dx of 7, negative 2, meaning that's the slope at 7, negative 2. If you remember, we already found the slope of 7, negative 2 in part C, and we got that to be negative 1. So remember, I'm going to erase this up here, that from C, earlier in the video, that dy dx at 7, negative 2 was equal to negative 1. So now I'm ready to substitute in the point 7, negative 2 in for the x and the y values here. And remember, my goal, because I'm working with the second derivative, to determine concavity, my goal is just to determine, is this a positive number, meaning my graph is concave up, or is this a negative number, meaning the graph is concave down? So let's put in the values here. So I got that y value here. The y value is negative 2. So I got 3 times negative 2 squared minus 2 times negative 2 minus parentheses 4 minus 2x, so my x value being 7, times 6y, my y value being negative 2, times dy dx. Remember, dy dx at 7, negative 2 from part C is negative 1. All over 3, my y value is negative 2 squared minus 2, all that squared. Okay, so here we go. Negative 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. So I got that first number to be 10 times negative 2. Let me give a better spacing here. I gotta go kind of slanted, sorry. Minus here, negative 2 times 7 is negative 14. 4 minus 14 is negative 10. 6 times negative 2 is negative 12. Negative 12 times negative 1 is positive 12. Divided by negative 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. And 10 squared is 100. So now I just want to simplify this. 10 times negative 2 is going to be negative 20. And then negative 10 times 12 is negative 120. But I have a negative out front, so that's going to be positive 120. All divided by 100. I'm going to kind of try to squeeze this in here. Sorry for my whiteboard space being slightly insufficient. negative 20 plus 120 is 100, and 100 divided by 100 is 1. Remember, all we cared about is whether the second derivative is positive or negative. I got 1, I know that's positive. Positive means my graph is concave up, so I can then say concave up. And I don't need to write any further justification, but if you wanted to, you could say because the second derivative, d squared y dx squared is greater than 0. Because you've shown all this work, it should be clear to the reader that they know exactly what you're doing here, and so I don't have to write any more explanation. Alright, so we finished parts A, B, C, and D. We're on to part E. On E, what they want to know is, can the curve have vertical tangents where the graph crosses the y-axis? So, and then we have to explain our reasoning. So let's think about what this is saying here. Our first thing we need to understand is, can the curve have vertical tangents? A vertical tangent would be when the slope is like this, which would be, the slope would be undefined. So the slope would be undefined in this case where the denominator is equal to 0, or if we're dividing by 0, that would give us a slope of undefined, where our graph would have all rise and no run. In this case, that would be when this is equal to 0. So that's when our curve's going to have vertical tangents. And then they want to know, is that true when the graph crosses the y-axis? When our graph crosses the y-axis, the original curve, that's when the x value is 0. That's when that's essentially a y-intercept. So let's work our way through this. First, I want to see, can the curve have vertical tangents? I want to see where the curve would even have vertical tangents at. So that's when I have dy dx equals 4 minus 2x over 3y squared minus 2. So we have vertical tangents when the denominator equals 0. So vertical tangent when 3y squared minus 2 equals 0. And then we can add the 2 and divide by the 3, so I get y squared equals 2/3. And then we can square root this. Remember, when we square root, we get a plus or a minus in front of that. So I get plus or minus radical 2 over 3. We could try to break this radical down and rationalize it, but guys, I'm just going to tell you it's a lot easier if we don't, and we can just stop right here. We are okay with leaving our answers kind of like this. So far, this is the y values where my graph has the possibility of having vertical tangents. Now, I want to know, they said, where the graph crosses the y-axis. So that's when the curve, when the x value of our curve is equal to, when the y value is equal to 0. Let me see. When it crosses the y-axis, would be like a point here. That would be some point like 0 comma something. Okay? So that's when the x value is 0. Sorry, I misspoke. When the x value is 0. So what we need to do is put x is 0 in here and solve for that point. So when we do that, we have when x is equal to 0 and y is equal to this. What we're going to do is, let me gather myself. When x is 0 and y is this, what we're going to do is put both of these points into this original curve. If, when we put x is 0, and then we'll start with positive radical 2 over 3, when we put that into this original curve here, if, when we multiply this all out, it equals 34, then our answer is yes, it is possible for our graph to have vertical tangents when it crosses the y-axis. If, when I put in 0 and radical 2/3 in here, it doesn't equal 34, then this point is not a point on our curve, and so then our answer is no, it's not possible for our graph to have a vertical tangent when we cross the y-axis. So I'll try the point 0 radical 2/3, and I'll try the point 0 negative radical 2/3. So let's try both of those. If I was really cool, I would try them both at the same time. I'm not that brave today, so I'm going to try just 0 radical 2/3. When I do that, that's putting 0 radical 2/3 into the original curve. So the original curve being 2y cubed minus 4y plus 2x squared minus 8x equals 34. When I put that in, remember I'm putting in for the y value, I'm putting in radical 2/3. And for the x value, I'm putting in 0, because that's when my graph crosses the y-axis. So at this point here, I got 0 here, and I got 0 here. And so we're just seeing at this point satisfies, and it equals radical 34. When I do that, this cubed is some big number, so I can just write that as, I can cube it, I guess. This is 2 times 8 over 3 cubed is 27. Minus 4 times radical 2/3. I guess I don't need the parentheses anymore. That 0, this equal to 34. There's no way that's true. And so I've shown that the first point, 0 radical 2/3, that's not possible. So my answer here then is not, no, or not possible. I'll just say not possible. And I believe this is sufficient explanation. We showed that this point doesn't satisfy the equation. The other point I would then check, again, would be 0 comma negative radical 2/3. You'll notice negative radical 2/3, nothing else cool is going to go on here where like stuff's going to all of a sudden add up to 34. So I can already predict it's not going to be possible, but I want to show my reader that I know what I'm doing here. So I'm going to show, I'm going to jump straight to the substitution here. Minus 4 times y plus 2 times 0 squared minus 8 times that equals 34. For the y value, I'm putting in negative radical 2/3. And for the x value, I'm putting in 0. Again, I'm testing out this point now into the original equation here. Again, nothing cool is going to happen here. This is just going to stay negative. So this is going to be like, I don't know, negative 2 times square root of 8 over 27 minus negative 4 times the negative is going to be plus 4 square root of 2/3. That's all 0. And my question is, does this equal 34? Not a chance. The only way this will work out is if these things squared out and didn't have a radical, and we can maybe do some more math to simplify that. This doesn't happen here. So again, they're not equal, and so therefore we say it's not possible. At this point, again, we've finished now parts A, B, C, D, and E of this problem. Hopefully, I have answered it to you in a way that makes sense to you guys. And if so, would you give me that big thumbs up at the bottom? And until next time, guys, have a good one.